Okay, 4.4 part 2. It's going to take all of the stuff that we've been talking about the last few days, last couple weeks, and we're bringing it all together because we're going to talk about all 4 quadrants. Before we talked about finding sine, cosine, tangent, and their reciprocals only in the first quadrant where everything was positive. So now we're going to go one step further. We're going to talk about all 4 of the quadrants. So it's important to understand and be able to visualize and figure out the signs of x and y in each of the quadrants. So in quadrant 1, x is what, y is what? In quadrant 1, what are the signs of x and y? Positive, positive, right? Okay. In quadrant 2, what are the signs of x and y? X is negative, y is positive. What about in quadrant 3? Negative, negative, good. And then in quadrant 4? Positive, negative, right? That's going to be super duper important, guys. Another thing to understand and to be able to visualize is where the different where the different trig functions are positive and where they're negative. If you notice in quadrant 1, all trig functions are positive because the x value is positive, the y value is positive. What do we know r is always? R is always positive. So in quadrant 1, sine and its reciprocal, cosecant, cosine and its reciprocal, secant, and tangent and its reciprocal, cotangent, are all positive. Everybody see that? In quadrant 2, sine and cosecant are positive, and the rest of them are what? Negative. So cosine and secant are negative. Tangent and cotangent are negative. In quadrant 3, what's positive? Tangent and tangent and cotangent. The rest of them are going to be negative. All right, and that should make sense because tangent is y over x, right? So a positive divided by a positive is a positive. A negative divided by a negative is a positive. And then in quadrant 4, cosine and secant are positive, and the other stuff is negative. Now you guys are going to say to me, oh my gosh, am I supposed to memorize that? You don't have to memorize it. I'm going to give you an acronym. If I say PEMDAS, what does that stand for? Please excuse my dear Aunt Sally, which stands for? Parentheses, exponents. It's our order of operations, right? Well, we're going to talk about an acronym that's going to help you remember this, all right? Think of this quadrant as A. This quadrant is S. Why do you think I made that quadrant? Not me, but why is that quadrant A? Why is the first quadrant A? All of them are positive, okay? Why is the second quadrant S? Not some, that's good, but not, that's funny. Sine, and it's reciprocal. So what do you think the third quadrant is? What letter? T, good. Tangent and cotangent. And then what do you think the last quadrant is? C, for cosine and secant. So you guys are like ASTC, okay? Here, in quadrant 1, all functions are positive. This is my A quadrant. In quadrant 2, sine and cosecant are positive. Everything else is negative, so that's our S. In quadrant 3, tangent and cotangent are positive, so that's our T. We're talking about where things are positive. And then in quadrant 4, cosine and secant are positive, so this is our C. So we have some mnemonic devices down here. Right, the book says, instead of please excuse my dear Aunt Sally for PEMDAS, the book says, okay, fine. For ASTC, we'll say all students take calculus. All right, there's another mnemonic device that some people use. All snakes tease chickens. Another one, a smart trig class. So we are going to use our mnemonic device of all students take calculus, wink, 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 and we're going to apply it. And I'll show you how you're going to apply that right now. Right, here is a very basic question that some of you came up to me yesterday on your website, and you're like, how do I do this? And I said, tomorrow, right? So now we got it. This question involves absolutely 0 numbers. You're not adding, subtract, nothing. You're going to use our all students take calculus. You are given here 2 constraints, they'll say. You have to use the first constraint to eliminate some things. Then you use the second one to find the answer. What I mean by that, all right? Let's write out our mnemonic device. Let's write out our quadrants. In the first quadrant, all things are positive. In the second quadrant, just sine and its reciprocal. In the third, just tangent and its reciprocal. And in the fourth, just cosine, its reciprocal. So when they give you these two constraints, these two math sentences, if you will, you can eliminate different parts of your coordinate plane to figure out where theta lies. So the first one, you can't do them both at the same time. You got to look at things separately. So the first one says cotangent is greater than 0. All right, that's telling us a lot of information. When we refer to cotangent, that also involves what? Tangent, good. And if something is greater than 0, is it positive or negative? Positive, all right? So this first thing is telling me that this angle lies in a place where tangent and cotangent are positive. So think about that. In the first quadrant, are tangent and cotangent positive? Yep, okay. In the second quadrant, are tangent and cotangent positive? No, so it can't be there. In the third quadrant, are tangent and cotangent positive? Yep. And in the fourth quadrant, are tangent and cotangent positive? No. So every time we do this, we'll be able to cross off 2 the first time. Now I look at the second statement. With what I have left over, I can now narrow down where theta lies. It says the second statement is that sine and what? Sine and cosecant are less than 0. What is that telling you? That they're negative. So with what's left over, guys, where are sine and cosecant negative? In quadrant 3. Because what happens in the first quadrant? They're all what? Positive. So your answer here would be Q3. Do you see how we did that? You got to think a little bit. You're going to have to narrow down with the first thing, and then the second thing will help you to figure out with what's left over. Does that make sense? All right, let's look at the next one. Again, you're finding where does theta lie. So draw your coordinate plane. All students take calculus, right? My first constraint, my first thing says cotangent and tangent, good, are less than 0. That means they're what? Negative. So where are cotangent and tangent negative? Is it in the first quadrant? No. Is it in the second quadrant that those two things are negative? Yep, could be. Is it in the third quadrant where those two things are negative? No. Is it in the fourth quadrant where those two things are negative? Yes, okay. So I know it's either 2 or 4. The second piece of information will tell me everything. It says secant, well, what goes with secant? Okay, so secant and cosine are greater than 0. That means they're what? Positive. So with what we have left over, where are secant and cosine positive? Where are secant and cosine positive? In the fourth, right here. So your angle lies in Q4. Questions? Moving along. Now, how do we apply that? These are 2 different examples. All right, this first example right here says, given cotangent of theta is -4/3 and sine is greater than 0, find the following. You guys are like, all right, well, this is kind of like what we've been doing. In order to find all the trig functions, you need x, y, and r, right? So if they tell me that cotangent of theta is -4/3, what are they telling me when they say cotangent? What over what? It's x over y, correct? You guys agree? Okay, great. Now, where does that negative go, with the x or the y? Do we know where it goes? Do we know where we should apply it? Hold on one sec. We're going to figure out why. First of all, let's use our all students. We got to figure out where this angle is. And then we can figure out what sign x has and what sign y has. Given that cotangent is negative, that means what else is also negative? The tangent. So where can this angle lie if cotangent and tangent are negative? Could it be in the first quadrant? No. Could it be in the second? Yeah. Could it be in the third? Why not? Because tangent's positive. Good. And it could be in the fourth. Okay, so I'm not sure. I'm not sure if x should be negative yet or y. I know one of them is, not both of them. So the second thing tells me that sine is greater than 0. What does that mean? Sine is what? Positive. With what's left over, guys, where is sine positive? In quadrant 2. Okay, so I know that this angle is in quadrant 2. Why is that important? Well, think about it. In quadrant 2, what are x and y in quadrant 2? X is negative and y is what? Positive. So now you know what gets the negative and what gets the positive. So you know that x equals -4, y equals +3, and we can figure out what r is. R will always be what kind of a number? Positive. We did like 3 examples yesterday where 2 of the legs were 4 and 3. Right? If I use the Pythagorean theorem, -4 squared plus 3 squared equals r squared. So 16 plus 9 equals 25. So square root of 25 is 5. Do we now have all the information we need to do our trig functions? Yes. Sine is y over r. Cosine is x over r. Secant is r over x. And cosecant is r over y. So now that we know what the legs and the hypotenuse are, we know what the sines are. This part's easy. What's the sine? What's the sine? 3 over 5. What's the cosine? -4 over 5, okay. What's the secant? -5/4. And then what's the cosecant? 5 over 3, right? Once you know what the legs are and what the hypotenuse is and what the sines are, the trig function part is easy. All right, so come to something like this, all right? This could be a little tricky. There's a few ways that you could do this. You guys know that you're going to identify the x value, the y value, and the r value. You know that r is always going to be what kind of a number? Positive. All right, now we're not sure if x and y are negative, if one of them is negative, if both of them, that sort of thing. This is going to help us figure it out. But when they told me the tangent, what did they tell me? Y over x. So I know that y is 1 and x is 5, right? You guys agree? Okay. So by them telling me that the tangent is positive, how do I know that tangent's positive? God bless you. How do I know that tangent's positive? Because I'm looking at it, right? And it says positive. So I know that, could it be in the first quadrant? Yep. Could it be in the second quadrant? No. Third? Yep. Fourth? No. Okay. That second piece of information is going to tell me everything I need to know. It says cosecant. Cosecant is what reciprocal? Okay. Sine and cosecant are less than 0. What does that mean? What does it mean if something's less than 0? It's negative. So what can I cross off? A or T? A. So I know that this angle lies in the third quadrant. Well, why is that so important? It means that both the x value and the y value are what kind of numbers? Negative. Now you guys are like, but the tangent's positive. Yeah, because a negative divided by a negative is a positive. All right, so guys, gone are the days that I can give partial credit because you forgot your negative sign, right? By you forgetting your negative sign means you are evaluating a trig function of an angle that's in a different quadrant than the one that you should be. So you have to make sure your signs are correct. Now, if I'm trying to find the r value, I would simply say negative 5 squared plus negative 1 squared equals r squared, right? So negative 5 squared is 25 plus 1 equals r squared. So what's r equal? The square root of 26, right? You guys will not have a calculator on your quiz. I will be mindful of the numbers. I'm not going to make them ginormous, but you don't need a calculator. You guys need to be able to reason through this, and then you got to, you have to do the square root of 26 in your head, and if it breaks down. But now to do your trig functions, sine theta, cosine theta, tangent theta, and the reciprocals, you guys could all figure that out now, right? Because we have our x, y, and our r. The hard part, the trig part, is figuring out what the sine of y and the sine of x is, which quadrant we're in, that sort of a thing. All right, does that make sense? Just comes with practice, I promise. All right, now we're going to talk about something called reference angles. Right, reference angles. It says, let theta be an angle in standard position. The reference angle is an acute angle formed by the terminal side of theta and the horizontal axis. All right, I want you to write this down, and this needs to be true. Stay in your head, so you guys always check this, and I'll show you a million times, but it's a good way to check yourself. Reference angles, angles, that's angles, right? Are always two things. Always. Positive and acute. God bless. What does acute mean? Less than 90 degrees. So if you are going to check yourself and you get a number and you're like, oh, I think this is my reference angle, and it's negative 17, you did something wrong. It has to be positive and acute, both two things. All right, and it's important to remember that it's formed with the horizontal axis. Which one's the horizontal? X, right? Okay, so let's talk about how to find reference angles. If your angle is in the first quadrant, what do we know about all the angles in the first quadrant? They're two things. They're positive and acute. So if your angle, if theta is in quadrant 1, theta equals the reference angle. If the angle that they give you is in quadrant 2, the way that you figure out the reference angle is you say 180 minus theta. That'll give you your reference angle. If your angle is in quadrant 3, you say the angle that they give you minus 180. That equals your reference angle. And if your angle is in quadrant 4, you say 360 minus the angle to get your reference angle. Now, some of you are like, oh my gosh, that's so much to remember. It's really not. It's really not. I'll show you why. I'll show you how you can remember some things. Show you how you can check to make sure that you are answering the question correctly. But when we talk about a reference angle is formed by taking a vertical line from the terminal side is where the angle ends, down to the horizontal axis. So your reference angle is formed right here. So if you're in the third quadrant, you go from the terminal side up to the x-axis, and here's your reference angle. If you're in the fourth quadrant, you go from the terminal side up, and there is your reference angle. But if you guys notice, it's always formed with the x-axis, correct? Yes or no? So on the x-axis, on your unit circle, would you guys agree that 0 and 360 are on the right-hand side? And what's over here on the left-hand side? 180. Should you ever use 90 or 270? No. What axis is 90 and 270 on? The y. Your reference angles are formed with the x-axis. So if you can remember, you're only using x-axis, so that's 180, 360, and that your angle needs to be acute and positive, then this is not that bad. This is not that bad, I promise. So So let's look at how to figure this out. I'll show you. These are 3 different examples. On your quiz, you won't have one like B. I'll show you how to work it out, but you won't have one like B because you won't have a calculator. But the first thing you do is you look at your angle and you say, okay, I have an angle of 300 degrees. Well, I have to figure out, some of us can visualize this, some of us can't. Who cares if you can't? Draw a little picture. This is 0, 360. Up here is 90. This is 180. And this is 270 down here, right? So think about 300. 300 is in between what 2 numbers? 270 and 360. It's over here somewhere. What quadrant is that? 4. So your angle that they gave you is in quadrant 4. What is the rule for quadrant 4? 360 minus the angle, which is what? 60 degrees. Check your answer. Is that number positive? Yes. Is it acute? Yes. You're good. If you were confused and you're like, I don't know, I'm gonna say 300 minus 180. Okay, so if you do 300 minus 180, you will not get an acute answer. If you say 300 minus 270, you're going to get a small number. It's going to be acute, but then is 270 on the x-axis? No, you have to remember you're dealing with the x-axis. So 180, 360, and your answer should be acute and positive. Now, when I go to do this problem, do you see a degree sign? No. So this is in radians. So how do you convert, guys? How do you convert from radians to degrees? 180 over pi. Now, do you see a pi symbol that you can just cancel out? So what you do when a conversion like this, when the pi is already built in, you'd multiply 2.3 times 180, which is what? What's 2.3 times 180? Somebody for me, please. Okay, so you get 414, and then divide that by pi. What's 414 divided by pi? 131.7. Okay, so this is 137 degrees, and then you guys can figure it out where that is. If you had a calculator, yes, you could do that. I am not going to have you multiply 2.3 times 180 and then divide it by 3.14. But if we were to find the reference angle for this one, where is 131.7? It's in quadrant 2. So what's the rule for quadrant 2? What's the rule for quadrant 2? You would say 180 minus 131.7 and get your answer. Okay, that makes sense? All right, let's come over here. All right, negative 135. All right, so think about this. Negative just means direction, right? So this is negative 90 down here. It's the opposite. Negative 180, negative 270. So where would negative 135 be? It's over here in quadrant 3 somewhere, right? So what's the rule for quadrant 3? The angle given minus 180. So negative 135 minus 180. What does that give me? Anybody? What's 135 and 180? 220? 215? 3, what is it? Negative 315. Well, wait a second. What did we say our reference angle has to be? Positive and acute. Well, that's not the case. So what do you guys think we do? Why should we add 360? To find the coterminal angle. Very good. If you're given a negative, guys, just find the coterminal. When you're given a negative, the first thing you do is find the coterminal. You need something in order to find terminal. In order to find a reference angle, you need something that is between 0 and 360. So if it's less than 0, find the coterminal. If it's more than 360, find the coterminal. Just add if it's less than 0, subtract if it's more than 0. Good. So guys, if you add negative 135 plus 360, what do we get? How much? No. Just start from right here. I mean, you could. You just have to go. Because all you did there was 180. You didn't do a full circle. So negative 135 plus 360. It's going to give me what? 225? Okay. What do we know about about coterminal angles? If this was my original, negative 135, when I added 360 to it, did I come back to the exact same spot? I sure did. Right? This is 0, positive 360. This is 90. So that's positive 180. This is positive 270. So think about it. When I go here to 225, am I not in the exact same spot? It's just a positive number. Now we can find the reference angle. If you're in quadrant 3, what is the rule for quadrant 3? We already talked about it. It's the angle minus 180, right? So your angle is 225 minus 180 gives me how much? 45 degrees. Is 45 an acute positive angle? Good. Very good. All right, I'm going to do these last two examples, and then I'll finish this up tomorrow. All right, example 7 says find the reference angle, sketch it, blah, 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 blah. But, guys, where is 2 pi over 3? What quadrant is 23 pi over 6 in? What do you think we could do to figure this out? We could convert it, absolutely. Let's go ahead and convert. The only thing that I have to remember to do, I have one extra step. If I start off in radians, I have to finish in what? Radians. So I'm starting off in radians, 2 pi over 3. Well, let's convert it and figure out where that is on my circle. So my pi's will cancel. 3 goes into 3 once. 3 goes into 180 how many times? 60. What's 2 times 60? 120 degrees. God bless you. So think about 120. Here's 360, 90, 180, 270. Where is 120? It's in quadrant 2, right? It's over here somewhere between 90 and 180. So what is the rule for Q2? 180 minus theta. So 180 minus 120 gives me 60 degrees. Is 60 an acute positive number? Yes. But I started off in radians, so what should I do? I need to convert back. So those of you who don't do this on your quiz, and then when you get your quiz back, I'm like, God, can't we should put 2 points up? She's the worst. It's okay. It doesn't make me cry. Can I simplify here? 60 goes into 60 one time, right? 60 goes into 180 how many times? 3 times. So what is my reference angle? Pi over 3. Question. Elliot. Elliot asked, couldn't you have just done pi minus 2 pi over 3? Did you know at the beginning that, without looking at the unit circle, that 2 pi over 3 was less than 180? Was less than pi? Okay, because that would be 3 over 3, right? Like you can visualize that, that's fine. If you can do that and don't need to convert, that's fine. But like 23 pi over 6, right? That wouldn't, not necessarily. Why are you saying quadrant 4? I'm not saying you're wrong. Just why, like, are you assuming that it's in quadrant 4? Like, why do you say quadrant 4? Okay. That's fine. If you can do that, if you can think that way, that's totally fine. Somebody just, first period we did that, and they said, well, because it was a big number, they thought it was in quadrant 4. So I just wanted to make sure you're reasoning. Guys, if you look at 23 pi over 6, you guys aren't 100% sure. We think really much better in degrees. You're welcome to do exactly what Elliot was just doing. She said that, well, 4 pi, think about what 4 pi would be. 24 pi over 6 would be 4 pi, right? Yes? So you can think that way, and then you say, oh, okay, well, it's going to be in the fourth quadrant, whatever, however you want to look at it. I think it's easier for us if you guys just go, okay, let's convert. Let's figure out where this is. If I break this down, my pi's cancel. 6 goes into 6 once. 6 goes into 180. How many times? 30 times. And now we multiply. 23 times 30. It's not that bad. Multiplication. What's 23 times 3? 69. Then just put the 0. So 690 degrees. What do you guys notice about 690? It's bigger than 360. So what would I do here to figure out where on my coordinate plane 690 is? I'm going to subtract 360. So when I subtract 360, what do I get? 330, all right? Where is 330 degrees? Quadrant 4. Some of us don't visualize that. That's fine. This is 360, 90, 180, 270. Where is 330? It's over here, somewhere in between 270 and 360, right? So what's the rule for quadrant 4? 360 minus the angle. So what is 360 minus 330? 30 degrees? All right. Only problem is we started off in radians, so we need to do what? End in radians. So 30 over 1, we're going to go 2 radians. 30 goes into 30 once. 30 goes into 180 how many times? 6 times. So your reference angle is pi over 6. Now again, if you want to think in terms of radians, that is perfectly fine. I just think sometimes it's easier for us, especially if we don't have our calculators, to convert because we think better in degrees. But whatever works for you guys is fine.